Then you have glyceraldehyde phosphate. Then unsay sunod ani? 1,3-biphosphoglycerate. 1,3-biphosphoglycerate. Then you have here ATP. There's another ATP here. Then 3-phosphoglycerate. You have 2-phosphoglycerate isomerization. Of course, naatay NADH. So, naatay NADH food here. Then you have PEP, phosphoenol pyruvate. And then you have pyruvate. So, two molecules. Then there's another ATP here. So you have ATP. We have ATP. Okay. Now, when glycerol is broken, class, so we may actually compute, no? Say glycerol is broken, converted into dihydroxyacetone phosphate. Then dihydroxyacetone phosphate is converted into glyceraldehyde triphosphate. And then 1,3-biphosphoglycerate. Then we have 3-phosphoglycerate. So there is ATP. And then phosphoglycerate, 2-phosphoglycerate, then PEP or phosphoenol pyruvate, then 2 pyruvate molecules. Then you have the ATP. So for every molecule of glucose or glycerol, it can give you have here, you count. So if, of course, this is only for, isa rin siya kakuan. Kami siya kay, this comes from fructose 1,6-biphosphate. But this one, ang glycerol, kanila isa na ka molecule. So, kana na siya. So, mo na ni iyahang na-produce out of breakdown of glucose in glycolysis. Kaya ni-enter niya siya sa Krebs cycle. I mean sa glycolysis. Kaya kaning isa out of the splitting of the 6 carbon atoms sa fructose. So, muna yung nalimong duha. But this time, kung ang glycerol na-convert into dihydroxyacetone phosphate, mahiba siyang glyceraldehyde triphosphate. So, kana ra siya. Then, kani, times 3 man na kung maadtong electron transport chain. So, pila? 1, 2, 3, so 3, 4, 5. So, limited. Okay? For breakdown of glycerol. Okay, Dumayra, no? However, there is still ATP generation for glycerol breakdown. Got it? Okay. Now, of course, naapag yun ay pyruvate. Duha ka molecules sa pyruvate. Or say, kanino mo siyang pyruvate, so isa lang ka molecule di ay. Isa ka molecule kang ang 2, that is good for the splitting of fructose 1,6-biphosphate. But for every glycerol, isa ra iyang product. So, isa ka cycle, isa ka another additional of 1 ATP, and then upat ka NADH, then usa ka FADH2. Daghan gihapon. Daghan gihapon. Are you with me? So, kung nauna mo, pila na. Okay. So, that is the energy yield or yielded out of the breakdown of glycerol. Now, how about the fatty acid breakdown? So, fatty acids in triglycerides are the principal storage form of energy. Now, fatty acids can give you more, around 3 times more ATP than glucose breakdown. In fact, these fatty acids are very efficient in terms of energy generation. No? Very, very efficient. Why? Because for every molecule of fatty acid, it can give you how many? It can give you, say, if this is your glucose, say in terms, convert into kilocalorie, or say, i-convert into energy or kilogram per gram. So it can give you, say, one breakdown of glucose molecule, it can give you around 3.8 kilocalories. For every gram of glucose, for every gram. However, for a fatty acid, of course, there is difference depending on the type of fatty acid. But say, the longer the fatty acid, the more energy it could give. The longer the chain of this fatty acid, the more energy or ATP molecules it could generate. Okay? Like this, palmitic acid. Ang palmitic acid can give you around 9.3 kilocalories, which is 3 times more energy than the breakdown of glucose. Okay? So, kung mukaon ka o ibutang mo kanon, rice, compared with cheese, na nasa pizza, abinin mo lighter lang. Kunya ang cheese can give you times 3 in terms of kilocalories per gram of that of the rice you ate. So it can give you more. Kunya, sabang pagkakuan. Nilukab. Kailangan makabukaan na. Grabe yung pizza. And cheese. Grabe. So how many kilocalories you gain? So mo lang, burot yan. Burot na yun. Okay? Because every molecule of fatty acid, it can give you around, or say, 3 times more of the ATP or energy than the carbohydrates or the glucose. Now, say for example, if we have 36 ATP as the net, so times 3, pila? 18 carry 1, 3 times 3, 9, mga 100. Up ATP production. So, up more than 100 for every fatty acid breakdown. Yeah, wala napot na sa glycerol. Napay glycerol class. So, in ana ang energy, you have gained. Yeah, kaya matulog raman mo. Pag man ka o pizza, matulog. Yan yung study sa biochemistry. Tulugan naman. So, that energy is being stored. So, tulahin mo ng bil-bil. Longer storage. Okay, so that will be stored in the adipose tissues, in the muscle, in the liver. Okay. Okay. So, the breakdown of fatty acid. So we will know the details how this fatty acid is broken down. Now this is explained in beta oxidation. The breakdown of fatty acid mechanism explained in beta oxidation. This is a series of 5 enzyme catalyzed reactions that cleaves carbon atoms 2 at a time from the carboxyl end of a fatty acid. So we'll start here from reaction 1. Okay? Now, you have to take note of this, Okay. The fatty acid must be activated first. Because fatty acid is an inactive form. We have to convert it into active form of a fatty acid. So, of course, when it is activated, so we have here acyl-CoA. This is an active form of fatty acid. So, the fatty acid again is converted into an active form called acyl-CoA. So this is an active form of fatty acid. That is step 1. Then step 2 is the oxidation of the alpha, beta, carbon-carbon single bond to a carbon-carbon double bond. So the acyl-CoA is converted into trans-enoyl-CoA. Of course, this is participated by the enzyme called acyl-CoA dehydrogenase. So this is step 2. Acyl-CoA, which is an active form, is transferred or transformed into trans-enoyl-CoA by acyl-CoA dehydrogenase. Reaction 3 is hydration of the carbon double bond to give a secondary form of alcohol. So the trans-enoyl-CoA is converted into L-beta hydroxyacyl-CoA. L-beta hydroxyacyl-CoA. So that is the result of the hydration of trans-enoyl-CoA. So trans-enoyl-CoA to L-beta hydroxyacyl-CoA. Okay. Next is the oxidation of the secondary alcohol to ketone bodies. So we have here ketone bodies, which is one of the intermediate products of the breakdown of fatty acid. So the beta hydroxyacyl-CoA converted into beta ketoacyl-CoA. So this is a ketone. This is a ketone. And of course, you have here production of the NADH. So before, you have the NADH, electrons are released. So electron transfer chain, NADH. So this ketone body undergoes cleavage. So ketoacyl-CoA to split siya into 2 molecules, nag-cleave siya into 2 molecules. We have the acyl-CoA and the acetyl-CoA. Now, acyl-CoA is the active form. Pubalik na po na siya dito sa step 1. So, we also already have the acetyl-CoA. Now, this acetyl-CoA class enters the Krebs cycle. So, enter na po siya sa Krebs cycle. Now, remember, kaning acyl-CoA, balik na po siya dito sa step 1. Balik siya sa step 1. Now, this cycle of reaction is then repeated on the short-end fatty acid chain and continues until the entire fatty acid chain is degraded to acetyl-CoA. So, ang target is to degrade ang tanan nga chain sa fatty acid. Ang bawa C18 or carbon 18. Tanan nga chain dapat ma-convert into acetyl-CoA. Unay target. So, katong acyl-CoA, balik to siya sa step 1 ng pod. So, nanapod siya diri sa kanisya, enter na siya sa Krebs cycle. Acetyl-CoA. Pila to siya kabuo. Mubalik-balik na siya. Mubalik siya sa step 1 na sad. Then, there will be more accumulations of this acetyl-CoA. So, you have here acetyl-CoA, pila ka buok na. Nakay-production of acetyl-CoA ang resulta. Sa first cycle lang ha, it gives you 8 NADH and 8 5H2. First cycle lang ani. Pila ka, depende sa pila ka chains of fatty acid. So, magbalik na po na siya sa second chain. Okay, third, fourth, hangtod mahurot ang chain of fatty acid up to the last chain until all the acetyl-CoA all will be converted into acetyl-CoA. Okay? Now, that oxidation of unsaturated fatty acids proceeds in the same way with an extra step that isomerizes the cis double bond to trans double bond. So, we have 4 steric acid class. For For stearic acid, which contains 18 carbon atoms, 18 carbon chains. No? So, ka-18 siya magbalik-balik atom. No? Now, it can give you 146 ATP molecules per steric acid molecule.